Good morning, everyone, once again, and thanks again for joining us for our second part of Cscape 9.9 SP4 overview. Today's session, we have three presentations, not that long. We're going to do Enhanced IEC migration. We're going to do register-based advanced ladder to variable-based advanced ladder migration. And finally, we're going to show you how to create a bootable disk for firmware. I'll talk more about that when it comes to it. And again, as usual, if you have any questions throughout the presentations, just ask them in the questions panel of your control panel, and we'll answer them separately after each one. Our first presentation, as I said, is on Enhanced IEC. It is if one decides to move from standard IEC to enhanced IEC, this presentation tells you what needs to be done with regards to migration and some of the added features that may need your attention. So we'll make a start on that. It's about 16, 17 minutes long. And as I said, if you have any questions throughout, by all means, please ask in the question panel and we'll answer them afterwards.
Hi, today we'll be showing you how to use the new features included in Enhanced IEC. In this session, we will cover the following topics. We will do a recap on creating a new IEC application in Enhanced IEC mode by default. We will cover migration from IEC to Enhanced IEC. We will cover modifications required in Cscape applications after migration, and we will include demonstrations. We will cover new string function blocks available on Enhanced IEC, and we will finish with a Q&A session. First, let's look at Enhanced IEC environment setup. In order to set up Enhanced IEC mode as the default mode for creating IEC applications, go to Tools, Application Settings, and select Enhanced IEC Default Enable option from Support Program Types section. Then select Apply and OK. To migrate an existing IEC program to Enhanced IEC mode, navigate to Tools, Editor Options, Compiler Options, and select Enhanced IEC mode. Cscape will display a warning message that target device needs to be licensed, so click OK to continue. Cscape will display another warning message to maintain a backup of the current program file. You click Yes to continue and No to return to the IEC program. Enhanced IEC mode is now enabled. Once an IEC program has been migrated to Enhanced IEC, there are some situations where the programmer will need to modify the migrated program. The IEC function blocks highlighted in red below will cause a compilation error in the output window. These blocks will need to be replaced with the corresponding Enhanced IEC function blocks. So for example, the Modbus master function block will have to be replaced with the corresponding Modbus Do Request / old user master, and so on down the list. Hi, in this next demonstration we will be showing you how to configure Modbus Do Request master block of Enhanced IEC in Cscape. The existing Modbus blocks will not work in Enhanced IEC, as there is no mapping of registers supported in Enhanced IEC. When we convert any existing IEC application to Enhanced IEC and compile, there will be an error indicated for any block that are not supported by the Enhanced IEC runtime. When this occurs, the Modbus master IEC blocks will need to be replaced with the new Modbus Do Request master blocks. Let's describe the Modbus Do Request. Initially, we will need to open the port by assigning the required port configurations in the Open Communication block. Then, configure the Modbus Do Request block. Here, we have to apply the port number, which is already opened above, a timeout value in milliseconds, a trigger variable, and the MCB variable and input data. Specify an array of Boolean or word variables. Based off the Modbus offset command, this data will either be written to the slave or will be read from the slave. For this demonstration, I've used the Modbus Slave simulator. The program has already been downloaded to the controller, so go to debug mode in the Modbus control block and assign a slave ID of 1. To write data, apply a Modbus command of 16 and an offset of 0, with the data length set to 2. Now, edit the data value to write this to the slave device. Open the Modbus Slave simulator and trigger this block so now the data is transferred. If you want to apply an offset, then you set it here. Again, energize the trigger bit. In the simulator, the data is now written with an offset of 5. This is the controller reference offset. Again, apply a value of 7, so data from this offset will be written to the slave. Trigger the block again and view the updated data in the simulator. Next, we will be showing you how to configure a Modbus Map Slave block in Enhanced IEC. In Enhanced IEC, the Modbus Map Slave block is equivalent to Modbus Slave block in IEC. As mapping of registers is not supported in Enhanced IEC, we need to create the variable arrays for holding registers, input registers, coil bits, and input bits. Data is transferred based on the Modbus command from the master device. The master here is a simulator device connected to the MJ port of an XL7. Create an array of holding registers of length 10 in the simulator, as in the controller Cscape program, the array size of holding registers is also set to 10. All 10 variables will be transferred from slave to master. If the length exceeds more than the array size in the Cscape program, then the simulator will flag an error, a legal data address. To read input bits, the data will come from this variable array, input underscore bits. As you can see right now, all are off. Set one input bit to true. This status is reflected in the simulator. Set another input bit to true, and again we see the updated status in the simulator. If we need to write coils, then we need to select the Modbus function 15 write multiple coils in the simulator. As these bits are already true, let's make them false. As you can see, all are in a false state now. Similarly, for input registers, we need to select the simulator Modbus function as 04 read input registers 3x. Change this value, and the value is updated in the simulator. Next, we will demonstrate how to configure the Ethernet resident protocol Modbus Slave using Enhanced IEC. In Enhanced IEC, there is no tagging of registers, so the configuration window has changed to reflect this. This is the new configuration window for Modbus Slave configuration. We need to configure variables including the array size as per the program requirement for Modbus holding registers, input registers, coil bits, and input bits. I've created these, each with an array size of 10 as indicated here in the configuration window. The variable setup can be viewed in the Program Variables window. The file has already been downloaded and the controller is in run mode. So let's go to Debug and then open the Data Watch window. For demonstration, I'm using a simulator as the Modbus TCP client. This is connected to LAN 1 of the controller. In the simulator, I have selected holding register 1 and assigned the length of 10. Using the controller Data Watch window, write a value in the first holding register variable. Here, we can see the data transferred. Now, modify a value at the simulator end. The updated value can be seen for the corresponding holding register in Data Watch. If the array length of the variables to be read or wrote from the master exceeds the configured array length, the simulator will display an exception response from the slave device. If you want to read an input register, then edit the array in Data Watch. the data from this array is transferred to the client. Here I have edited input registers and the updated values can be seen in the simulator. The value is updated in the simulator. Coil status can be written at both the slave and client ends. Set coil_bit 0 to true in DataWatch and view it in the simulator. Then, from the simulator, force another coil to true. To read input bits, the data of this variable array, input bits, from DataWatch is transferred. Force this first input bit state to true in DataWatch and we can see it updates in the simulator. Similarly, force the second input bit and see it change to true at the simulator client. Next, we will be showing you how to configure networking blocks in Enhanced IEC. The networking blocks in IEC are not supported in Enhanced IEC, so migrating a program which features networking blocks to Enhanced IEC will cause an error on compilation. The blocks will need to be replaced with the equivalent blocks available in Enhanced IEC. Here we have an IEC program for an XL7E with a netput word block. I will now convert this program to support Enhanced IEC and compile it. As you can see, there is an error indication function block is not supported by the runtime. In this instance, replace the blocks with those that are available in Enhanced IEC. I have created an IEC program with the equivalent block. In Project Toolbox, under Networking, we can see the existing IEC blocks put n words, get n words, put n words with send command are disabled. The Enhanced IEC version for these blocks is net put word, net get word, and net put word x. Now I will show you how to configure these blocks in Enhanced IEC. The first is the net put word block, which transmits data to the network. Input to these blocks are ID, source, IO reference, IO start index, and number of words to transmit. In the ID, insert the node ID, which is transmitting, which is the local ID, and SRC, the source, and specify the starting variable where the data is to be transmitted. IOREF specifies the starting IOREF, which must be AQG 16-bit or QG, which is 1-bit, Cscan networking data. IO start index is the start index for the IOREF. For example, to transmit the data starting at AQG1, then specify 0 here. N is the number of words to be transmitted. Next is the net get word block, which receives data from the network. The block inputs are similar to net put word above: ID, IOREF, IO start index, destination, and number of words. ID is the ID of the controller that is transmitting data. IOREF specifies the IOREF of that controller. Again, these must be AQG or QG. IO start index is the start reference for the IO index. 0 for AQG1, 1 for AQG2, etc. In this block, I have programmed the block to receive data from AQG12, so I have assigned the start index as 11. Destination is the local variable where the data is received, and once again, N specifies the number of words to receive. Similarly, for netput word x, the inputs are similar to netput word, with an extra input for a send command. When this bit goes high, the data will be transmitted ignoring any change of state in the source data. To show this operation in the controller, I will now download the program. I have set up an XL7E connected via Cscan to an RCC controller. The XL7E is transmitting this data source. The IO start index is 0 and the number of words is 10. The RCC is receiving the data from the ID node 1. IO start index is 0 and the number of words is 10. The RCC of ID 253 is then transmitting this same data back to the network with the IO start index as 11, which is being received at the XL7E. This program is already downloaded and running in the RCC. In the XL7E, I'm transmitting the data system registers SR44, which is the real-time clock seconds value, to source variable index 0, which we can get in the RCC destination address. Open debug mode for the RCC, and here we can see the first data value is incrementing. This is the real-time clock value being transmitted from the XL7. Now I will change some value in the XL7. You can see here the first one is transmitting the real-time clock second. Now I will change the second word. I will add the incoming destination variable here also. The second value is now also visible as being received using the netget word. We're going to finish this tutorial by moving away from Cscape and talking more about Enhanced IEC migration. If a program is migrated to Enhanced IEC and multiple program variables are mapped to the same register address, then if the same memory locations are being used as a single storage point and are then referenced by two different variables, then on compilation of the program, Cscape will give an error as shown. The solution to this problem is to remove multiple program variables mapped to the same register address. If a program is migrated to Enhanced IEC, then if there are variables mapped to the internal registers %r, %m, or %t, then on compilation of the program, Cscape gives the warning as shown. The solution is to open tag by double-clicking on it, delete the assigned internal variable register, and press enter or return. Here's the list of the new function blocks available in Enhanced IEC. Array to string, which copies an array of int to a string. Char ASCII code, gets the ASCII code of a character within a string. ASCII to hex, converts string to a hexadecimal integer. String concat, concatenates strings. CRC16, calculates a CR16 on the characters of a string. Delete chars, delete characters in a string. String find, find position of characters in a string. Hex to ASCII, converts a hexadecimal integer to a string. Insert chars, inserts characters to a string. String left, extract characters to the left. String mid, extract characters from any position. String replace, replace characters in a string. String right, extract characters to the right. And lastly, string to array, copies the characters of a string to an array of int. Now I would like to thank you for listening so far. Next, we will move on to a live questions and answers session.
Okay, so that's migrating from IEC to Enhanced IEC and the nuances related to it. I just have one question in here. Why have we removed %rs, etc.? Because it's not that we've removed them. The memory is still there, but the assignment to %r and %t and %m, the internal memory addresses, is no longer required. Originally, when we brought in IEC into Cscape, the IEC section of Cscape worked on variables, but the other editors within Cscape, so the things like the graphics editor and recipes and data logging, required registers. So that's why we had the option of tagging variables to registers. There was also a limitation in standard IEC that you had access only to 10,000 register addresses. So with Enhanced IEC, that's all been removed. 64,000 registers are now available, the full array. So that can be used. As well as that, you know, with the mapping removed, we also have implemented, I mean, it's security really. I think I'm just leading into another question here. Does it mean that there is no longer offset for register to read by Modbus Slave? Yes, I mean, okay, previously, and this is one of the reasons why you'd need to address any Modbus blocks within your IEC to Enhanced IEC. So previously, you just set up your block, and we had an internal memory map that if the master wanted to, it could access any location within the internal OCS memory map. So we've removed that now. So now you need to define the array. So if you want to define an array of holding registers, you define obviously the variable and the array, the number of holding registers you want to define. And then directly by accessing with the standard Modbus holding register addressing 40,001, etc., that'll hit your first holding register. That's how that mapping works now. So I mean that's very useful. As I said, it eliminates the access to our entire memory map, which has been the case all along up to now. Anything else here? Let me have a look. Is Enhanced IEC faster? Faster than what? Okay, it is. And again, going back to one of the reasons, it's a new engine, okay, in the firmware, so it is faster. Removing the architectural layer for accessing the registers directly, so tagging the registers, actually increases the performance of Enhanced IEC runtime. And it also reduces the compilation time. Anything else here? No. Okay, so we'll move on. Just to reiterate, I mean, if anyone is interested in any of the program demos that have been done during the presentations, contact the tech support email and we can send you on these examples if required. The next presentation is again on migration. This time it's from register-based advanced ladder to variable-based advanced ladder. So this is a reasonably short one, less than 10 minutes. So we'll see you on the other side. Again, questions throughout if necessary.
Hi, today we will be talking through migrating a program from advanced ladder to variable-based programming. This presentation will cover the following: the migration tool to convert advanced ladder programs to variable-based programming, naming conventions, the variable-based programming editor watch window, the increase in ladder size, and we will end with a Cscape demo. From Cscape 9.9 SP4 onwards, Cscape allows migration of an advanced ladder program to a variable-based programming. Open any existing advanced ladder program, right-click on the opened program in your project navigator and select the option Convert to Variable-Based CSP. Once the user selects Convert to Variable-Based CSP, Cscape will display the message seen in the image here. Selecting Yes displays a Save As window prompting users to save a new file for the converted file. After successful conversion, Cscape will display the following message, giving details of the logic size before and after the conversion. There will be an increase in logic size after the conversion to variable-based programming. This is due to the newly created program variable data. The advanced ladder program is now successfully converted to a variable-based program. If there is any program error, Cscape will pop up the below message before converting. If user selects Yes, the program will get converted with errors as it is. If user selects No, the program will not get converted. System registers used in advanced ladder programming will get converted with predefined variable names in the variable-based program. For example, %S7 will get converted to ALW_ON. Registers with IO names in advanced ladder programs will get converted to variables with the name given in the IO name section. these variables will be tagged to those registers. Registers without an IO name in Advanced Ladder will get converted with default naming as var_xxxx, where xxx is the register used. For example, %R200 in Advanced Ladder will get converted to var_R200 in the variable-based program. In Advanced Ladder, if the same register is used with different data types, then after conversion, variable names are created with data types as suffixes. For example, if R200 is used as int as well as dint in Advanced Ladder, these will get converted to var_R200 16-bit and var_R200 32-bit. After conversion from Advanced Ladder to the variable-based program, the user can change the variable names as per their requirement. Each variable should have a unique name, so the user cannot assign the same name to different variables. Cscape will give an error message if the user tries to modify the name and there is a duplication of said name. The data watch window for variable-based programming has been changed to have the variable name in the first column. Also, memory tagged for the variable is displayed in the last column. While converting the program from Advanced Ladder to variable-based programming, there is an increase in logic size due to the newly created program variable data. They are also downloaded for uploading later. To overcome this logic size, XL and X series OCS has been increased from Cscape 9.9 SP4. Logic size of the X2, X4, X7, X10, XLE, XLT, XLEE, and the XLTE has been increased from 256 KB to 512 KB. Logic size of the XLE, XL4E, EXL10E, EXL6E, EXL6EW, X5, RCC8842, RCC2414, RCC972, RCC1410, and XL Plus have been increased from 1 MB to 2 MB. We will now go through a Cscape demonstration of this new feature. Hi, today we'll be taking you through the steps of migrating Advanced Ladder with registers to variable-based programming in Cscape. First, open an existing program from the Project Navigator. Next, right-click on the program name and select the option Convert to Variable-Based CSP. Cscape will pop up this message to keep a backup of this current file for future use. Click on the Yes option. After clicking Yes, a window will pop up with the option to save this file, and we're going to give it a different file name here. So now we can see the conversion progress window. In this conversion window, we can see which part of the conversion is going based on the number of registers and I/O modules used in the normal ladder. It may take several minutes for this conversion. We will start the conversion by clicking on the Start button. So now we can see which part of the conversion is currently going on, and you can see the file has been successfully converted. In this pop-up window, you can see the logic size before the conversion is 0.06%, and logic size after conversion is 2.27%. Here, the increase in the logic size after conversion is due to the newly created program variable list. So next, we're going to click on OK. Now we can see the registers are replaced by the variable names. You can see in the logic editor, system register S7 used in normal ladder replaced with predefined variables. Now click on Tools and go to the program variables to see the register R100 replaced with the IO name AI_%. We used same registers as a 16-bit and 32-bit, so two variables have been created, one for the 16-bit and one for the 32-bit. You can see, as per the variable name, both are tagged to R200 registers. Other registers which don't have any I/O are converted with naming conventions var_register name. Here we have a timer in Advanced Ladder with tagged programming. Timers only accept predefined structure variables, but functionality-wise the block will work as is. So now I will show you how it is working, and then we will modify the block. To download the program, go to the program menu, look down to download, select it, and click on OK. And then a window will be displayed showing your download in progress. And now the download has been completed successfully. To debug the program downloaded, select the debug menu and go to debug. Now you can see the values in debug mode. To modify a variable from DataWatch, open the DataWatch window and click on Add Variable to select the variable. Select the variable from the drop-down and click OK. To change the values, double-click on Value and change it. Now we can see the timer is working. If required, we can edit the timer block to instead use the predefined timer structure in variable-based advanced ladder. This is the timer variable, so in data type we need to select predefined structure data type, and we do not need to give any dimension. Double-click on the timer block and select that variable from the drop-down, and click OK. To create any new variable in the Program Variable window, right-click on the Program Variable window and select Add Variable. So now a new variable with the default name newVar is created. To modify the name, double-click on it, edit it, and press Enter. Each variable should have a unique name, and we cannot have a duplication of names, as it will pop up an error. We can tag the variables, or we can create the variables without tagging. Cscape will auto-allocate the registers when we compile the program. Now I've created the variable without tagging and downloaded the program. So, the download is in progress and now completed. Now we will add the newly created variable in the DataWatch window, and we can see the variables which we did not tag as Cscape has allocated for us for T1 and T2. Similarly, for this integer variable temp, Cscape has also allocated R3 register. We'd like to thank you for listening so far, and next we'll be moving on to our live questions and answers session.
Okay, so that's migrating your register-based advanced ladder to variable-based advanced ladder. And what needs to be done, bring one to the other. Now, again, these are migration tools. So, I mean, if you're creating a new project, you can develop it, obviously, directly using either of the options in variable-based or enhanced IEC, if required. Those are just for migration purposes. Any questions in on this? Let me have a look. Can the variables list be exported and reused? Yes is the answer to that. They can be exported in XML format, and they can be then reused by bringing them back into the variable editor. I think you right-click on the variable editor and load IO names from file, I think it is off the top of my head, and then select the XML file and bring that in. That'll bring the variable list into your current program. Are variable names case sensitive? No, they're not. Not case sensitive. Anything else? Let me see. No, I can't see any other questions on that. Finally today, we're going to talk about, and we're going to present to you, bootable firmware creation utility. You're probably all familiar with, I hope you'll all be familiar with our website and how you grab the current version of firmware. Generally, we make it available as a zip file or compressed file with the individual files included for your controller or the controller you need to update. You download that, extract it, put it onto a micro SD or a USB in the case of the Linux-based controllers, XL4, XL7, etc. Go to the system menu, or at least press and hold the system key for a few seconds until you get into the bootloader menu, and then press install bootloader, wait a minute or so, and unit resets, your up firmware, and all other pertinent files are updated. We have now decided to include a bootable microSD creation utility. And this is done because, on occasion, if the firmware update doesn't go right, or for any other reason where there may be a firmware corruption for whatever reason, you may need to recover the unit completely. So what you need to do is you need to run this bootloader utility. We'll go through it. It'll create a bootable microSD, and it'll enable the controller to boot from the microSD card. Doesn't do anything with the internal memory or firmware. It boots directly from the microSD card to allow you to recover your unit fully. So up to recently, we used, it's a batch file creator, we used a utility called CF Imager, and we realized that from some reports and some internal testing, that CF Imager is not fully supported by Windows 10. So there were issues updating firmware or creating bootable disks with that imager. So we brought in this utility called Rufus. Some of you may be familiar with it. Rufus is an open source, free to use, free to distribute bootable disk creator. So we've implemented that with our firmware files. It's extremely fast. Anyone that's run a batch file to create a bootable disk before with our controllers, you'd be sitting around for 4 to 5 minutes, sometimes longer. This utility is seconds, can be measured in seconds. It creates a bootable disk, and as I said, allows you to recover or fully update your controller. So I'm going to show you a presentation on that now. And I'll talk to you again about it afterwards, because we'll have this up on the website shortly. Just bear with me now.
Hi, we're going to walk through the procedure of creating bootable firmware. So here, we click on Make USD Batch File, and we get the pop-up as seen. For the first step, we need to enter the controller we are using. For this, we are using an EXL6E. So from the list above, for EXL6E Cscan, we need to type in EXL6E. We are then prompted to enter the drive of our SD card. As you can see here, the drive for my SD card is F, so I will enter that here. Once that starts creating, Rufus will automatically pop up. No changes are required to be made to this Rufus pop-up, as it has been pre-configured. So we go ahead and hit the start button. From here, we will receive a warning that all data on the SD card will be destroyed. We click OK to this, and then we get another pop-up regarding drive partitions, and we will also click Yes on this window. It will then begin to write the image and shouldn't take too long. Once complete, we click on Close. As we see, it then returns us the batch file, where it starts copying the files over to the SD card. We should then see success, and we can click on any key to continue from here. So I'll come down over here to my SD card, and we can see the firmware files have been created. From here, I will eject my SD card, and we will enter this into the EXL6E, and can go through the process of applying this firmware. We have an EXL6E here. As you can see, we have our SD card in the unit. So with the unit powered off, we're going to hold the load button as I'm doing here, then apply power to the controller and release the load button. The controller now starts up and goes into bootloader mode. From here, we click on Install Bootloader. We are then prompted with the question, "Are you sure?" which we say yes to. This will now start to install, which can take up to a minute. I've cut to the point of the install finishing, and we are now met by this screen. The operation has completed, so we can press OK here, and we can remove the SD card and power cycle our unit. As we can see here in the View Status section of the System menu, the versions have been updated. Hi, we're going to walk through the procedure of creating bootable firmware.
There it was, starting again. Okay, that's the procedure to create a bootable disk to recover or update your unit. This will be available. I think you can all see my screen. I'm pretty certain you can. Yeah, you can. So I'm just sitting on the Horner website firmware page here. So after the session, or maybe live now, we'll need to log in to check. We'll have the software global voucher code that we discussed in the previous meeting, which will allow you to license, permanently license, free of charge, Enhanced IEC and MQTT on any controllers you wish to do so on. And again, just to remind you that that voucher will be available to license any controller up to the release of Cscape 10. We will have the firmware update manual up there. We'll also have another accordion here with the bootable firmware. So let's just have a, I'm currently not logged in because you can see all of my back-end areas there on the website. So we don't want to be showing you all of that. As you can see, the lock is here because I'm not logged in. So here's where you would normally download your firmware. And these are the zip files that you would just put onto a microSD or USB stick and update using the system menu. But you will have another accordion in here with the bootable disk creator. The video that we've just watched will be there, and also there's a written procedure as well there. So I would encourage you to familiarize yourself with that. It's a very quick and fast process. As I said, Rufus is less than a minute, about 30 seconds, I think, to create the files and then to copy them across and back in using the batch file. Now, we are currently working on our own internal utility to do this as well, to make it a bit more transparent. So you just select your controller, the firmware, whether you want 2 or 4 counters, etc., and off it goes. But that's not available as yet, but it will be soon enough. So do we have any other questions here? I can't see anything in. Just remains for me to say thanks for attending again today, guys. Service Pack 4 and the firmware. Sorry, I didn't mention the firmware. The firmware will also be released now, 1550. So thanks for joining us for these 2 overviews. We'll keep in touch with upcoming webinars. We plan to run these regularly over the coming months and for the foreseeable future. So I hope you all have a good rest of the week, and we'll let you know when the next webinar is happening. Thanks and goodbye.